Hey everyone, and welcome to Cognito Key. Today, we're going to pull back the curtain on one of the most important but maybe least understood parts of your computer, cache memory. It's the secret ingredient that makes everything you do feel lightning fast.
You know that feeling, right? You unbox a new computer or a new phone, and it just flies. Everything is instant. Well, a huge part of that magic isn't just the main processor, it's a clever little assistant working behind the scenes. So, what exactly is this secret? Let's dive in. Okay, so to understand this, I want you to imagine your computer's CPU, that's the central processing unit, as this absolute genius. It can think and calculate at unbelievable speeds, but it has one big problem. All the information it needs is stored in the main memory, or RAM, which is kind of like a giant library, a really, really slow library.
Let's try another analogy that I think really helps. Think of the CPU as a master chef who can chop, cook, and plate dishes in seconds. Now, the main memory, the RAM, is the big pantry with all the ingredients. The only catch? The pantry is all the way at the other end of the building. So every single time the chef needs an ingredient, they have to stop everything, run down the hall, find it, and come all the way back. It's a huge waste of time, right? This delay is what we call a bottleneck, and it totally wastes the chef's talent.
So, what's the solution? It's actually pretty brilliant. We give the chef a small spice rack right next to the stove. And this is exactly what cache memory is. It's a tiny but super fast storage area that keeps all the most common ingredients, the data and instructions, right where the CPU can grab them instantly. And here are the key things to remember about it. Cache is much smaller, way faster, and because of that, a lot more expensive to make than your regular RAM. It's designed to be this perfect middleman sitting between the lightning-fast CPU and the slower main memory, making the whole system run smoothly.
This whole system leads to two really important ideas, a cache hit and a cache miss. So when the CPU needs some data, the very first place it looks is the cache. If the data's there, bam, that's a cache hit. Our chef just reached over and grabbed the salt from the spice rack. It's incredibly fast. But if the data isn't in the cache, that's a cache miss. Now our poor chef has to make that long, slow trip down the hall to the main pantry. The whole goal of the system is to get as many hits as possible and avoid those misses.
Okay, but that brings up a good question, right? How in the world does the cache know what to keep on the spice rack? I mean, it's so small, it can't hold everything. Well, it works because of a fantastic principle about how computer programs actually run. It's called the locality of reference.
Basically, it all comes down to this. Computer programs are creatures of habit. They don't just jump around randomly accessing data from all over the place. They tend to work in one small area for a while, often using the same instructions over and over again in loops. This predictability is the secret sauce that lets the cache make a really educated guess about what the CPU is going to ask for next.
And this locality idea actually comes in two main flavors. The first is temporal locality. Think time-based. It just means that if the CPU just used something, it's probably going to need it again very soon. So you better keep it close by in the cache. Then there's spatial locality. Think space-based. This one says that if the CPU accesses a piece of data, it's very likely to need the data stored right next to it in memory. So when the system fetches one thing from the slow pantry, it's smart enough to grab a few of its neighbors too.
Now, it gets even cooler. Modern computers don't just have one single cache. To squeeze out every last bit of performance, they use a whole hierarchy of caches. Think of it as multiple levels, each with its own special balance of speed and size.
So, when the CPU is looking for data, it's a step-by-step hunt. First stop, the level 1, or L1 cache. This is the tiniest and fastest of them all, built right onto the same piece of silicon as the processor. If the data isn't there, it checks the L2 cache, a little bigger, a little slower. Still no luck? It moves on to the L3 cache, which is bigger and slower still. And only if it strikes out on all three levels does the CPU finally give up and make that slow journey to the main memory.
And if we want to get just a little more technical, there's another clever design choice here. Caches can be split or unified. A split cache, which you usually see at the L1 level, has two separate sections, one just for instructions and another just for data, kind of like having one rack for spices and another for cooking oils. A unified cache, on the other hand, holds both together. The modern ways to get the best of both worlds: use super-fast split L1 caches and then use flexible, unified L2 and L3 caches that can adapt to whatever the program needs. But of course, like with anything in technology and engineering, this amazing speed doesn't come for free. There are always trade-offs.
Cache memory is a brilliant solution, but it's not a perfect one. It's all about balancing the pros and cons.
The advantages are pretty obvious, right? It's so much faster than main memory, and because it's right on the chip, it keeps traffic off the main system highways. But here's the catch. The technology used to make cache is very, very expensive. And because of that, the size is incredibly small. We're talking about a few megabytes of cache versus many, many gigabytes of RAM.
And that really is the main takeaway here. Cache is the perfect example of quality over quantity. Without this tiny, expensive, but strategically brilliant layer of memory, our incredibly powerful processors would just be sitting around, twiddling their thumbs, waiting for data. Everything would feel slow and clunky.
So the next time you tap on an app and it opens in a flash, or you're switching between 10 different tabs without a single stutter, take a moment to thank your computer's cache. It's that invisible assistant, that personal spice rack for your CPU that's working tirelessly to make your digital life feel instant.
I really hope this explainer helped you understand a little bit of the magic happening inside your devices. If you found it helpful, we would love it if you'd subscribe to Cognito Key. And of course, please like and share this with anyone else you think might find it interesting. Thanks for watching.